All right, so here's a Hooke's Law example. This is a pretty typical type for this section. Most of the Hooke's Law problems will look something similar to this. This is problem 24 from section 5.3. It says a 2-pound fish stretches a spring 3 inches. How much work is done stretching it 3 more inches? Now, why you're putting a fish on your spring, I have no idea, but I didn't write the problem, so there you go. Anyway, we always start here by finding the spring constant. The spring constant will be different for each problem, so every time you start a new problem, this is your first step. But we know that force equals K times distance. And in this case, it says a force of 2 pounds stretches the spring 3 inches. So dividing both sides by 3, K is just 2/3. Again, if you get confused which is which, remember force will be measured in some sorts of units that measure force, for instance, pounds, and distance will be measured in some sort of units that could measure distance, for instance, inches. So if you pay attention to the units, you should certainly be able to keep these separate. Once you've solved for the constant, the integration is ridiculously easy. It's just the integral of K times X dx. This will give us the work done stretching the spring. Now, it says how much work is done stretching it 3 more inches. Well, we know the spring has already been stretched 3 inches. So we must want to integrate from 3 to 6. That is, we've already stretched the spring 3 inches. How much work is done stretching it 3 more inches? Then, well, this is an easy integral. It's just 2/3 times x squared over 2 from 3 to 6. If you want to, leave the 2/3 on the outside. So that's 6 squared over 2 minus 3 squared over 2. And I think 36 minus 9 is 27 over 2. So these cancel. And 27 divided by 3 is 9. And this is measured in inch pounds, because those are our units for this particular problem. So the work done is 9 inch pounds.